So this video lecture will be for section 11.3, difference quotients. And that's the only objective, is to learn how to determine the difference quotient. This is a really important topic for moving on to calculus. The first thing you learn in calculus is about limits, and then you apply limits to these difference quotients, and you're started off into calculus. So let's remind ourselves about this function notation, that we read this f of x, and the word of is important. It's saying whatever the x is, that's the input to the function. So formally, f of x means evaluate the function at the value in the parentheses, if it's a number. So we're going to just do a little practice of, here's a function, f of x equals x over x squared plus 1. So we just want to do some practice writing the proper function notation. F of 0 is 0 over 0 squared plus 1, which is 0. So f of 0 is 0. So remind yourself that means the point 0, 0 is a point on the graph of this function. Then f of 1 means everywhere I see an x, I put a 1 and I get 1/2. So that means the point 1, 1/2 is a point on this graph of this function. C says let's find f of -1. So f of -1 equals -1, and this -1 that's squared has to be in parentheses. So we'll get -1/2. So the point -1, -1/2 is a point on the graph of this function. So then D says, well, what if I ask you to do f of the opposite of x? Well, that says put the opposite of x everywhere you see an x, making sure you put it in parentheses when it's squared. And you're going to have the opposite of x over x squared plus 1 when you simplify. So this is an odd function because it has this property that when I do f of the opposite of x, I get the opposite of the function I started with. So that's just an important property we'll learn more about. E says the opposite of f of x. Well, this means just put a negative in front of the whole function, and you can see that this is equal to f of the opposite of x for this particular function. So now let's look at what is f of x plus 1. Well, this says everywhere you see an x, instead put an x plus 1. And then you should simplify it as much as possible, remembering that x plus 1 squared is x squared plus 2x plus 1. So this is going to be x plus 1 over x squared plus 2x plus 1 plus 1. Or x plus 1 over x squared plus 2x plus 2. So that's f of x plus 1. Okay, then G asks us for f of 2x. So that says everywhere you see an x, now put a 2x. So you're going to have 2x over 4x squared plus 1. And then the last one is probably the most important for where we're going next. F of the quantity x plus h says everywhere you see x, put x plus h instead. And that's going to lead us right into the difference quotient. So the difference quotient of a function is given by this formula. It's f of x plus h minus f of x over h, as long as h isn't 0. So let's look at if x is a particular number a, because this can be an easier place to start. And what we're looking at is, suppose we have some function like this, and here is a. Then this y-coordinate is going to be f of a. And then if we walk just a little ways to the right on the x number line, that new x-coordinate is going to be a plus h. And if we then say what's the y-coordinate of that point, that's the f of a plus h. And then what we're looking at is the slope of the line between these 2 points. So it's the difference in the y coordinates over the difference in the x coordinates, or the slope of the line, exactly. So we're going to practice finding the difference quotient, and some students are able to just do this in one big step, and others find it easier to do step by step. Either way is fine. Here's what I'm going to recommend. Use A first, then replace it with x, and then later you can work up to putting x. So let's find f of a plus h first. So that says everywhere I see an x, put an a plus h. So that's 3 times a plus h squared minus 2 times a plus h plus 6. Then remembering that a plus h is a squared plus 2ah plus h squared minus 2a minus 2h plus 6. Then let's distribute that 3 all the way through the trinomial that follows. And keep copying. That is our f of a plus h, or the first term in the numerator. Okay, now let's work on just the numerator. So if I know what f of x is, then I know f of a is put a everywhere I see an x. So I'm going to do f of a plus h, which we just did above, minus f of a. So that's going to be 3a squared plus 6ah plus 3h squared minus 2a minus 2h plus 6 minus, make sure to put this parenthesis, 3a squared minus 2a plus 6. And then let's see what cancels. So I have 3a squared plus 6ah plus 3h squared minus 2a minus 2h plus 6 minus 3a squared plus 2a minus 6. So 3a squared is going to cancel, 2a is going to cancel, and the 6 is going to cancel. So what's left is 6ah plus 3h squared minus 2h. So this is the numerator. Okay, now we need to do the numerator divided by h. So this step is the divide by h. So we take the 6ah plus 3h squared minus 2h and divide by h. Well, notice that every term has an h in it. So I'm going to factor out h and then divide by that h. So my answer is going to be 6a plus 3h minus 2. And if you do it this way, then convert to 6x plus 3h minus 2 at the end, because Newton will want your answer with an x in it. So some people just find it easier to operate with the a. It seems less confusing. And then at the end, you can change it back to being an x. So I wanted to show you one more example, because these are tricky. If I do f of a plus h, everywhere I see an x, I put a plus h. And then if I do f of a, everywhere I see an x, put an a. Then I form this difference. That's why it's called the difference quotient. It has a difference in the top and then a quotient as you divide by the h. Well, these denominators have nothing in common. So you have to get a common denominator of the two denominators multiplied together. So it's not going to be pretty at this stage, but it's going to get a lot prettier. So I'm multiplying each fraction by a very cleverly chosen 1 that gets it to have the denominator that I want. Okay, so I'm going to have a plus 3 minus a plus h plus 3 all over this big denominator, a plus 3, a plus h plus 3. So let's distribute that negative. A plus 3 minus a minus h minus 3 over a plus 3 and a plus h plus 3. Well, if things don't cancel here, something's wrong, but let's see, we have a cancels and 3 cancels. Wow, all that's left is negative h over a plus 3 and a plus h plus 3. And then you should convert a back to x and have negative h over x plus 3 times x plus h plus 3. And that is your answer for the difference quotient for that function. So if you have any questions, let me know.